All right, give me a second, folks. I'm here. We're a little low on the camera angle here, so I'll scooch. That's not even a word. But I guess you guys can see me there. And give me a second. Okay, welcome to STEMwithKino.com. I am Kino. And if you are in the room, first off, it'd be nice if we had some volume. It's coming. 1 moment. There we go. I believe we have volume now. Anybody in the room, please let me know how I sound. If you can hear me okay. I am here. The camera angle is just a little bit low. But the board for the questions are basically all you need to see. And I promise I will work on that camera angle in the future. Who is in the room? Give me 1 second. I think we got this angle issue solved. There we go. All right, that's a little better. So we got the camera angle solved. All right, who's in the room? I want to know your location and the test you are preparing for. And if you guys can hear me, I'm not sure. I asked if the sound quality. All right. Okay. Good to see you, Penland, Lorraine. Please hit the like button. Leon. SIFT guys, oh my god. I am working on some videos now, and what I told you guys I would do, I will be doing it in virtual reality. This is actually the Oculus Rift, the virtual reality goggles, because it's really, really hard trying to fly a simulated helicopter just looking at a screen. So I built a whole new system, and I got the Oculus Rift virtual reality package, and I'm making adjustments to it now. The only thing, like at this point in time, what I see is not necessarily being recorded, like the three-dimensional images that I see, but it's crazy. Like when I put the goggles on, it's like I can actually reach out and touch the panel, make adjustments on an attitude indicator and all that and everything. I look right. I'm looking out of the right side of the helicopter. I look left. I'm looking at the co-pilot seat and out of the left side of the helicopter. And it's amazing. It's amazing. But what I'm trying to do is, and there is a way I can do it with, I think, OBS Broadcaster. I can actually capture how it looks in 3D. So I will be doing some serious SIFT videos, helicopter videos, in the future. So if you're subscribed to me, you will see them, and I will be actually flying and demonstrating some situations that you might see on a SIFT test, because I always felt like, you know, I wanted to do more for the SIFT people, and it's pretty cool. I got a UH-1 Huey. I got a Bell 407, and then I have like the stock package that comes with Microsoft Flight Simulator Steam. So guys, look forward to those videos. They're going to be amazing. When I can actually show you guys what I'm actually looking at and the way I'm looking at it in 3 dimension, it's crazy. It's crazy. I left LaGuardia and a Bell 407, went to the Statue of Liberty, Ellis Island. That's right in between New York and New Jersey. And I actually landed on Ellis Island. And there's it's crazy. It's like I'm sitting in the helicopter when I put the virtual reality goggles on. So, wow. I'm like the last, it took me a while to get it to work, but I finally got it to work. And, man, when it kicked in, it kicked in. I mean, and fully operational. So we got that up. Okay, so you guys know where to send your questions to. If you are new in the room and you do not, I am posting my email. And that is the email that you send your questions to. What you can do is take a picture with your smartphone, send it to, send it to KenoThomas@gmail.com, and let's dig in. And again, like 8:30, if you guys are having questions that need to be answered, you can start sending them at 8:30. So this way I'll have like a rack of questions. I do have a rack of questions from people that are off, but I try to mix them up like one live stream. So I just keep lining them up like that in the docket. So, that's how we're working it. So let's dig in. Do I have? Yeah, I do have you connected. I'm talking to my external drive, guys. I'm not crazy, but I do talk to it. All right. Okay, let's look for something interesting. Okay, this is an aviation question, and it's concerning a stall. All right, now, as I spoke with you guys before, or I've talked to you guys about stalls in many other videos, how do we make a stall happen? A stall happens when we exceed the critical angle of attack. Every aircraft has one. Every airplane has a critical angle of attack. And if they exceed that critical angle of attack, then what's going to happen is you're going to lose laminar airflow. What I mean by laminar airflow, think of something laminated. When you have something laminated, you have the document and then you have the plastic very, very close to it, but the plastic is not the actual document. It just protects the document. So we have an airplane flying in this direction, and this is the wing, and it's flying in that direction. So as the air molecules approach the wing, they pretty much stick to it like that. And let's make a full slipstream. So this is the wing in the middle. All right, so just think of laminar airflow as like the wing being laminated with air molecules. That's why we call it laminar airflow. But when we pull up on the nose, pull up, and we exceed the critical angle of attack, which is angle of attack is the angle of between the relative wind and the actual chord line, which is an imaginary line between the leading and trailing edge. Then what happens is you have a angle formed. So the angle right here is like pretty sharp. Let's just say that's like 1 degree. All right, now when we pull back on the nose, or you pitch your helicopter up, because your main rotor blades could stall as well, for you SIF guys, and let's just say the angle of attack changed from this wing to this wing, then what happens is we get all of the bottom, but then we get something called airflow separation. So the air molecules are no longer laminating the airfoil or the wing, and this is what's going to make a stall occur. So let's just say this angle formed by the relative wind, which are the air molecules approaching it, is say 19 degrees. At 19 degrees, let's say if our critical, I'll put crit and alpha, or some people say AOA, at the critical angle of attack of 18 degrees, when we exceed that and we actually pitch up to 19, then what happens is the wing, the airfoil, or the rotors will stop producing lift. And the only way to recover from that is to just pitch nose down and get the airflow back over the wings at a certain speed. So that was a really good question. And I am looking for more. Okay. Cody, I have your question. What did I do with my little... Where's my little eraser, guys? What'd you guys do with my eraser? Okay. It's not even an eraser, it's just like a little rag. An old sock that I washed and I said, I'm going to use this for my dry erase. Okay, so the question says, hey Maria, how you doing? MEC, how are you doing? My professor said nobody knows why or how planes fly. Well, I do. Been doing it a long time. But anyway, we'll get back to you and your professor. All right. This is a mixture problem. And the way I teach mixture problems is I believe in just making my students think about containers. So we have container 1. It's going to be mixed with container 2. And at the end, we're going to have a whole mixture. All right. So it's saying, the question says, how much pure acid must be added to 10 ounces of a 55% acid solution to produce a 75% acid solution? So at the end of the day, we want 75% or 0.75. We write it out in decimal form because we are going to be mathematically or algebraically working with this number. All right, so we have ounces up top and the percent on the bottom, but we put this in decimal form. So we have 10 ounces, 0.55 represents 55%. So they want to know X, how many ounces of pure acid must be added to 10 ounces of 55% acid solution. So 1.0 represents 100%. And so this container is going to be mixed with this container. And at the end of the day, we're going to come up with this. And we want to know how much of this 100% pure acid are we going to have to add to the solution in order to come up with a 75% solution. So what I say is I multiply each container downward. And what I mean by that is ounces times the percent in decimal form plus ounces times the percent in decimal form is going to be equal to the new percentage that we're looking for times the sum of the two containers in ounces. So it's okay, don't freak out. This is how it goes. 10 times 0.55 plus, we'll just say 1x because 1 is going to be multiplied by x is equal to 0.75, and like I said, times the sum of, so we have 10 plus x. Okay, and just give me a couple clears, guys, if we are clear up to that point. If anybody does not understand what I did just now, like I said, we multiplied downward in the containers, and then it's going to be equal to the new percentage times the sum of the two containers in ounces. Give me a couple clears, guys. I know there is a time delay, and please hit the like button if you are enjoying this. If you're not, hit the dislike button. Doesn't matter, either one. Okay, we have a couple clears there. So now at this point, what we're going to do is we're going to multiply. We already did this ahead because 1x. That was like easy. So now 0.55 times 10. Now, a cool thing happens when you're multiplying by 10. If we multiply by 10, the decimal just moves over 1. So it's 5.5. You could go through all the math, but I promise you it's 5.5. But I'll show you. 0, 0, the filler 0, 5, 5. And we have 5, 5, 0, 2 decimal places, 1, 2, 5.5 like I said. But literally, if you multiply by 10, the decimal moves over 1. If you multiply by 100, the decimal will move over 2. If you multiply by 1,000, the decimal will move over 3 places. But it only moved over 2 places. So we have 5.5 plus 1x is equal to, again, we got another 10. So this is going to be 7.5. The decimal will move over 1 place. And these are rapid math techniques that you should learn. And if you watch my videos, you'll learn them. Plus 0.75x. Okay. So we multiplied this. This was okay. We multiplied it ahead of time. And then we distributed the 0.75 into the parentheses, getting 7.5 plus 0.75x. So 0.75 was multiplied by each term in the parentheses to get rid of it, because that's the first thing we have to do in order operations. We get rid of our parentheses. So at this point, we are going to combine like terms. So this guy is going to jump to this side of the equal sign and change signs, and we will have 0.25. And just think of it. If we take 75 cents away from $1, we're going to have 25 cents. All right. And then we're going to have 5.5 go to the other side of the equal sign, and it will become negative, and we will be left with 2. All right. And so I'm thinking quarters, 8 quarters, and x, I forgot to. So x is equal to 8. If we divide 0.25 on both sides, it'll cancel out on this side, and 2 divided by 0.25 is 8. So it will take 8 ounces. At the end of the day, we will have added 8 ounces, and we will have a total of 18 ounces of solution at 75% concentration. Now, why would you multiply down? I need an explanation for that reason. Algebraically, that's how it just works. When I teach this, that's how it just works algebraically. You must multiply ounces times the percentage plus ounces times percentage, and it will be equal to the new concentration times the sum. It's just the way it works mathematically. That's like asking, well, why would you put distance equals rate times time? That's just the way the formula works, how the system works. And this is how we solve mixture problems when we're trying to find a new mixture. I don't have a magical answer. So why? It's just somebody came up with this technique, and this is what is widely accepted when we do mixture problems. Just like distance, rate, and time is widely accepted. All right. Because a really smart guy at one point in time said, there you go. That's pretty much it. So a really smart guy came up with this way of solving mixture problems, and it works, and that's what I teach, because I set up the containers so you can see them. Now, when I do these, I just do this. 10 ounces times 0.5 and then 1 times x. I don't do the containers. I do the containers when I'm teaching it to give you a visual aid of what's going on. So you can see that this container is being mixed with this container to make that container. So that's why I do, because, that's probably a question of, well, why are you doing these containers? Well, that's why. It's just an easy teaching tool or method that I use, and it works. Okay. Keep sending those questions in, guys. And I have a distance, rate, and time question. Now, distance, rate, and time problems are normally come in the form of word problems. A little soda. Shouldn't be drinking soda, but I gotta keep my throat moisturized, ladies and gentlemen. I have a lot of speaking to do. Okay, so, matter of fact, why don't I just present this to the room so everybody could see? One moment, people. when we do word problems, line by line and diagram, that is my method. There's no magical formula. Before I do that, no, I'm just going to go ahead and jump in. Ooh, excuse me. All right. This is one that a lot of people have trouble with, and what I'm going to do is I'm going to give you guys 5 minutes. Nah, I'm just going to do it. That just seems like too much dead air. 5 minutes. All right, all of that. All right, nobody type anything. Nobody to type anything because I want you guys to see the full question. So here goes the first part of the question, and here comes the second part of the question. Okay, so line by line and diagram. So as I look at this, and you guys can see it now too, a cattle train left Miami and traveled towards New York. I'm going to draw a line. MIA, Miami, NYC. We'll put a cattle train here. All right. So, 14 hours later, a diesel train left, leaving 45 kilometers per hour in an effort to catch the cattle train. So this is the diesel train leaving 14 hours later. All right. And under here I put a note. We'll put left 14 HRS hours later. All right. After traveling for 4 hours, the diesel train finally caught up. So basically what I'm going to do is I'm going to put a DRT and a DRT here. The DRT stands for distance, rate, and time. The distance, rate, and time formula is pretty much the basis for all distance, rate, and time questions. Even if there's some variations, this DRT is what we're going to be using. So they want to know what was the cattle train's average speed. So I kind of went through it, and now I'm going to go through it like I would go through it. I just wanted to read the whole thing so you guys will know. All right, so the cattle train left Miami 14 hours later. The diesel train left, and the diesel train is moving at 45 kilometers per hour. So under rate, I'm going to put 45 km/hr. So 45 kilometers per hour in order to catch the cattle train. All right. After traveling 4 hours, this guy caught up. So under time, he has 4 hours. Now, for everybody in the room, how much time did the cattle train roll before it got caught? Anybody, just take a stab. If you're wrong, don't worry about it. This is where we make our mistakes, not on your test. $18 hours, very good. Because it ran 14. This guy left 14 hours later, and then 4 hours after the guy departed, he got caught. So under time here, we'll put 18HRS. So notice as we go through, we're diagramming and pedaling. Very good. Thank you. All right. So what we have to do is establish the distance. If this guy left 14 hours and then got caught in 4 hours by this train, wouldn't it be safe to assume that distance equals rate times time, which is 180? I think of 45 as half of 90. So 45 and a 45 is 90, and another 45 and another 45 is 180. 180 kilometers. All right. So if this guy traveled 180 kilometers, this guy traveled 180 kilometers. And in order to find rate, we just divide the distance by the time. There's only a 0 there, so that means that this was multiplied by 10. So 10 kilometers per hour is the speed, was the speed of the cattle train. All right. And it just works out. 18 hours, this guy rolled at 10 kilometers per hour. Distance equals rate times time, 180 kilometers. And this guy rolled 45 kilometers per hour, for 4 hours in an effort to catch the train. After 4 hours, he caught the train. 180 miles. Very good. Okay, so is there anybody that did not understand my process of how I executed my line by line and diagramming? If you didn't understand, don't worry about it. Just say something, I will explain it. That's why we're here. And I'm not crazy. There's a screen up and to the right a little bit where I can see your responses and stuff like that. How many clear? How many clear, guys? Give me a couple clears and we will move forward. Let me see, you sound like you're from Jersey. Clear. With no R. Clear. Clear, boss. I'm just messing with you. I know you just hit the space bar before you, I know you hit the space bar before you hit the R. It's all good. Nobody's, I'm not judging you. Don't judge me. Okay. If you guys didn't get that, don't worry about it. This live stream is DVR'd. And so after I close it out, it is being recorded right now as we speak. And you can look at it and you can pause and go through the examples that I am covering during this live stream. Okay. All right. This is a question that a lot of people have issues with. They kind of see them and they freak out. And I'm going to give you two examples. This concerns absolute value. Absolute value. All right. Absolute value come in brackets like this. And they surround, say, like a number or a number and a variable. So when we work this out, even if it's negative, we still look at it as positive because absolute value doesn't really care about positive or negative direction. It only cares about distance or units moved. All right. So basically what you're going to have is you're going to have two questions. So we have 6m equals 42. So you're going to have to break this into two problems. You will say 6m equals positive 42, and then 6m equals negative 42. All right, so we've taken this 6m equals 42, and we made it where the answer is positive and where the answer is negative. Okay, so what we do is we do our simple division, and on this side, m is going to be equal to 7, and on this side, m is going to be equal to negative 7. So that is the solution set. 7 and negative 7. And I have the little curly braces because this is not like coordinates. Coordinates would just have parentheses like this. So, you know, on some testing applications, they may have this as an answer. And if you choose this, you will be wrong. All right. This is what you want, the little funky little curly braces. I think they're called curly braces. I'm not even really sure if that's the proper name for them, but it's kind of like a parentheses, but it's got a little funky little point in the middle like that. At any rate, so this is the solution set. Now, what does that mean? That means I could put a 7 in here. 6 times 7 is 42. And I could put a negative 7 in here. 6 times negative 7 is negative 42, but since it's within the boundaries of the absolute value brackets, we look at it as positive. So negative 42 in absolute value is actually equal to positive 42 because it's just dealing with the number of units, not necessarily positive or like negative integers. Now, that one's cool, but sometimes people freak out when they see fractions, right? And that's okay, because here is where we clear it up. You have to understand the circular, what I call the circular relationship of the fraction equaling a whole number. What I mean by that is if we have 8 over 4 equals 2, then we need to understand that 4 times 2 is equal to 8. 4 times 2 is equal to 8. All right. So I would be like, okay, if there was an x up top, I would be like, what's 4 times 2? Well, x is equal to 8. All right. And I'll do this because that looks like an x and we want it to be like a multiplication symbol, which it was, but I don't want it to be misconstrued with an x. So this is how your question will look, though. You would get something like the absolute value of x over 7 is equal to 3. All right. So in that case, again, this is an absolute value problem. So we would say x over 7 is equal to 3. It's one problem. And then we would say x over 7 is equal to negative 3. Remember, in the previous case and in this case, we're setting the answer positive and then negative. We don't mess with this at all. Just that. All right, so again, understanding the circular relationship. In this case, x is 21. In this case, x is equal to negative 21. All right, because we're looking at the circular relationship of the fraction and the whole number. And 7 times 3 is 21, and 7 times negative 3 is negative 21. So our solution set would be 21 and negative 21. Now, some might ask, well, are you always going to get a positive, negative number in your answer? No, you will not always get it like that. I will show you an example of what I mean. Good job. Now I'm going to give you an example of what I mean. The answers are not always the same number, just one positive and one negative. I'll give you an example of what I mean, and then we'll move on to another question. We have k minus 10. The absolute value of that is equal to 3. So what we're going to say in our first statement is k minus 10 is equal to 3. In our second statement, we're going to say k minus 10 is equal to negative 3. Again, we set the answer positive and then we set it negative. We don't mess with that at all. We don't tamper with it. So in this case, k is going to be equal to 13. And in this example, k is going to be equal to 10 goes over becomes positive, and 7. So our solution set is 13 and 7. So we don't always get the same number like in the previous questions, like positive and negative. They don't always come like that. So, it's very, very important that you perform your order of operations so you come up with the proper numbers. Okay. All right. Okay. For my mechanical comprehension people, I have a question here, and I'm just trying to figure out how I can explain it in a way that everybody can understand. I'm always thinking about, okay, I can talk about something, but I want it to be simple. For my OAR and ASTB people, you're going to be presented with pictures, and you're going to have to be able to see the forces that exist in these pictures. All right. So the question that's being presented is a person is walking down the street and dribbling a basketball. And it's asking for the number of action and reaction forces. Remember, Newton's third law, for every action, there's an equal opposite reaction. And if you are SIFT, if you are OAR, if you are ASTB, I promise you, you're going to have a mechanical comprehension section, and there will be physics in it. Okay, so we have a person, and they're walking, and at the same time, they are dribbling a ball. All right. And so you'll see a person doing this, and what the question is going to ask you to do is to label action, reaction forces. And when I think of that, I always think of Newton, Sir Isaac Newton's third law of motion. Okay. So this is how I would do it. I see the person's weight being exerted on the ground, and I see the reaction, the ground supporting the person. The person is not falling through the asphalt, so the asphalt is supporting the person. Gravity is bearing down on the person's mass and then exerting weight onto the surface that they're dribbling the basketball. All right. The next force I see is the ball coming up to the hand, and the hand, we're dribbling, remember? So the ball comes up and the hand, boom, moves the ball back down. That is another action-reaction force. Or you could say, yeah, ball coming up, hand smacks it down. I also see the ball coming down to the ground and the asphalt, boom, making it spring back up. So that's 1, 2, 3. And then what happens when you guys see a basketball game? What do you hear as the players move? You hear the chirp, 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 chirp. It is friction of the feet and the surface having a stopping action because of the friction of the feet. So feet goes forward as the person is walking and dribbling at the same time, and the chirp from the sneakers because the asphalt floor or whatever the surface is providing friction. If anybody ever sees any other feet squeak, thank you, or screech, feet squeak. So Army SIFT, Naval, Marine Corps, Coast Guard, OAR, and ASTB people, you're going to have to look at pictures, and you're going to have to be able to label forces sometimes, because this has happened on the test where they just show you a picture and they'll ask you to label, I don't know, rotational forces sometimes, action, reaction. They may ask you which one, two pictures of the same person doing two maneuvers, which one's spinning faster, things of that nature. So it's very, very important that you can see these forces. And if anybody sees any other action-reaction forces, I'd like you to type them in now, but I think I have them all. So I see 1, 2, 3, 4 action-reaction forces as far as Sir Isaac Newton's third law of motion is concerned. And if you don't see any, just type clear and we'll move forward. TJ Harrison, you look new. What test are you preparing for? I don't want to assume you're a guy. Could be a female by the name of TJ. OAR, okay. So yeah, this is something that you want to be cognizant of. All right. Okay. All right, we got a couple clears. And TJ, I'd like to welcome you to the live stream. I'm here every Friday, starting at 9 o'clock. So, you know, this is a great resource. I'm telling you. I tutor for every military aptitude test that there is out there. And this doesn't cost you a thing. You get your book, snap some questions, or type them in. Go through your book, whatever you don't understand, send me the question on a Friday night. But also keep in mind that the book will not prepare you 100%. Everything that you see in these, that is published in these books are not on the test. This is something you want to be mindful of. And I would find a tutor that specializes in the OAR. I mean, if you want a competitive score. If you want to just keep applying for board, and possibly get passed over, then, have at it. But like I say, even if it's not me, and I say this every week, even if it's not me, find a tutor. It doesn't have to be me. All right. That being said, this is a good question. What is an absolute value function? That is a good question. Well, in order to understand functions, they come out like in the form of graphs. In order to pretty much find a line, you're going to have to need the slope-intercept form. And the slope-intercept form is y equals mx plus b. Just to give you an overview, m is the slope and b is the y-intercept. And that tells you where, based on a certain line, that the line is going to cross the y-axis. That's why we call it a y-intercept, because it intercepts the y-axis at a certain point. So the slope is its rise over run, and if it's negative, it's its fall over run. This is like the closest thing I could kind of relate to absolute value, but that's not like an absolute value equation. An absolute value function would be something like y equals x plus 1. All right. And if you get lost, they'll give you a bunch of graphs. And absolute value equations look like this. You have your y-axis and your x-axis, and they look like V's, like that. That's what an absolute value question looks like. Now, here's the thing. If I want to know some points on the absolute value in an absolute value situation, what I'm going to do is I'm going to make a table. Right? And let's just say that this was the absolute value function that they gave me. And it's absolute value function because the absolute value braces or containers there. What I'm going to do is I'm going to select, I'll do like, I don't know, 0, 1, 2, and 5. And if I do that, what's going to happen? Actually, I'm going to do a -5 as well. All right. So when I do this, what I'm actually doing is I'm going to plot what this function is. So if I put in 0, and I'm finding points. So if I put in 0 for x, then y is going to be equal to 1. So 0, 1. Is 1 point. Now, cool thing about this is telling you pretty much, I think, where the base of the V, where the bottom of the V is going to come to when you see that +1 and it's an absolute value. Let's explore some more points. If I put 1 in here for x, it's going to be 2. So 1, 1, 2. And then I'm going to say -2. So if I put a -2 here, plus 1 is going to be -1. So we get both sides of the V. So negative, hold up, -2. No, it's not -1. It's a positive one because duh, it's in the absolute value brackets. Whatever we work out here, even if it turns out to be negative, it's still going to be positive because it's in the confines of the absolute value bracket. So when we put the -2 in for x, we get -1, but it's thought of as a positive one. So I almost lost that one there. So we come over 1, 2, and then 1. And let's see, I want to do -1. -1 and -1 and +1 is 0. So -1 and 0. So I made a mistake, guys. When you see the +1 here, the V is going to shift in the negative direction, the bottom of the V. So you guys can see the V there. So when you see the -1, it's going to shift over in the negative direction. If it was a -1, it would shift in the positive direction. So that's how I handle absolute value functions. I just kind of pick some numbers for X and then find out what the Y results are. And then I'll just plot it out. So that when they give me a whole bunch of funky graphs like this, I know that this is the proper graph. And I know that was a lot, guys. But hey, they sent the question, so I had to address it. That person is at work. And so it's not like, all right. You know, so. All right. And was that clear to you guys? Because you could possibly get an absolute value function, and you should understand what's going on when you see them. Wow. You guys are digging deep tonight. Okay. Now, I've gone on and on and on about simplifying radicals. But not too many people in the live stream have asked about multiplication and division of radicals. And multiplying a radical expression, it's really not that bad. But you have to be really, really adept at simplifying. All right, so, and this applies to all tests. You could possibly get a question like this where you would have 3 root 12 times root 6. All right, and it's not bad initially because we don't have to really think or do anything yet. If there was a number here, a whole number, like there's a whole number here, this and the whole number would be multiplied together. But technically there's a 1 there. Okay, theoretically. So 3. But we have the radicals, so 12 times 6. What is 12 times 6, guys? I know it in my head, but I would like a little crowd participation. What is 12 times 6? $72. Good. So root 72. All right. The problem is that this is not finished. All right. So I actually can type in my name Kino and simplifying radicals, and you can understand how to simplify radicals if you watch that video. But I see root 9 and root 8, and then I see this breakdown into a root 4 and a root 2. All right, and again, go to my radicals video, and you can understand how I came up with that to simplify this. So, the 3 is still here. So this is like saying 3 times this 3 out of this 9 that made 9 times 8 equals 72. This root 9 is going to turn into a 3. And then the 8 is going to break down to a 4 and a 2. And this 4 is going to break down to a 2. And then we have root 2. So we have to multiply the whole numbers. 3 times 3 is 9 times 2 is 18. So our final answer is 18 root 2. That is the answer to that. Okay, I'll do another one. I'll do a couple of these. Square root of 5 times the square root of 10. Again, there's no whole numbers to deal with, so we just multiply the radicals. We get root 50. Okay, breaking that down, I see the square root of 25 and the square root of 2. The 5 will break down, the 25 will break down to a 5. Final answer is 5 root 2. And again, you guys can check the recording. A cool thing though, when you see 2 radicals, say this times this, then the radical just comes off and the answer is 6. That's a cool thing. So when you have 2 radicals, they're the same number under the radicand. The number, it just becomes the number. All right. To kind of show you like something like if I had the square root of 25. No, that wouldn't work. Well, times the square root of 25, it would just be 25. So this is because, actually, yeah. Well, think about the square root of 25. This becomes a 5, and this becomes a 5. And 5 times 5 is what? 25. So when you see two radicals with the same numbers, it's actually the number. And this was a really good example. I'll pause for a second because I couldn't mentally flow with it, but I found it. I got it back. So we have the square root of 25 times the square root of 25. When we simplify the square roots, we have a 5 times 5, and it equals 25. So we may as well just say that this number just forms one number. And the same thing happens here. Okay, was that clear, guys? Hit me with clears, buddies. Okay. All right, anybody in the room, if you need one-on-one tutoring, I can be reached at this website, stemwithkino.com. Again, I prepare people for all the military aptitude tests, officer and enlisted, and all Federal Aviation Administration exams as it pertains to pilots, from private pilot to airline transport pilot, all the flight instructor ratings and all the ground school ratings. I've obtained them all, so I understand the process and I know how to prepare for them. All the newcomers, I am here every Friday night, 9 o'clock. And if normally there's clients that have done at least 2 hours during the week with me, I normally do, when I have one or more of them, I do a Google chat, a Google Hangout, where it's a live video conference. So I'm here 9 to 10, and you guys can just hit me with all the questions you want, and that's how you get the most out of it. I had a healthy amount of questions tonight, but some nights it's like people, like you got a bunch of people in the room, and they just kind of, I know they want to kind of see questions worked out and stuff like that, but go through your book, find questions you don't understand, and bring them here every Friday night. So, there's really not anything that we are going to accomplish in 3 minutes. I have one clock that says 9:57, and I have one that says 10:03. That's interesting. But I'm willing to believe that it is 9:57. But I really don't think that, unless someone has a quick question, I'll take a look. And I don't see anything. So, again, I'm here every Friday night, 9 to 10. And then we normally do a live stream from 10 to 11. If I have a couple of clients that have done 2 or more hours with me, and that doesn't seem to be the case tonight. So I'll see you guys next week, and it is my time to give you the finger.